the quiz 4. The first question is about Tom Smith. In this question, the first part asks, well, for this courses, Tom has to read a book, and he can read 1 page per minute. And then Tom's boss has agreed to let Tom read in his idle time. So the question is, how many pages can he read? The real part is, what is the idle time? Well, to find the idle time, we need to find the utilization. So what is the utilization? Well, the utilization is P over AM, where P is the processing time, A is the inter-arrival time, and M is the number of workers. Well, the P, processing time, is 2 minutes. Inter-arrival time is 3 minutes, and there is 1 worker, making this 2/3. If the utilization is 2/3, the idle time is 1/3. Right? That is 33% of idle time. If the idle time is 1/3 or 33%, what it means is in 8-hour shift, you have altogether 1/3 of 8 hours as the idle time, which is equivalent to 2.66 hours. Remember, he can read a page per minute. That means he can read 2.66 times 60 pages in this much amount of time, which comes out to be about 160 pages. So identifying that really this question is about idle time, and idle time is related to utilization, is the most important part of the question. Well, the second question is asking how long does the customer have to wait. Well, that means we're interested in TQ. TQ, because this is a single server, we can use the easier formula, processing time 1 minus U times CVA square plus CVP square divided by 2. Well, the processing time we already found out was 2. Let's go find CVA on the side. CVA is the standard deviation of the processing divided by the mean of the processing, which we have the standard deviation of the inter-arrival divided by the mean of the inter-arrival, which is the the average is 3, standard deviation is 3. Similarly, for CVP, we know that the mean is 2 and the standard deviation is 1. So CVA is 3 by 3 equals to 1. CVP equals to 1 by 2, which is 0.5. Well, this part is easy. That means 1 square plus 0.5 square divided by 2. Now utilization we already calculated, 2/3 divided by 1 minus 2/3. I'll give this, trust you to do this calculation right. I got it to be 2.5 minutes. That means each customer has to, on average, wait 2.5 minutes to talk to Tom. That is, there is a hold of 2.5 minutes for every customer on average. Well, this question is, where's the phone bill? And remember, the hold time also counts against you. So on average, first let's get all the facts. Each customer holds for 2.5 minutes and spends another 2 minutes talking to the server, that's talking to Tom. That is, altogether, a customer stays on the phone for 4.5 minutes. Right? Remember, a call arrives every 3 minutes. Every 3 minutes. That means 20 calls an hour. If you are getting 20 calls an hour in an 8-hour shift, you get 160 calls. Each person stays on the phone for 4.5 minutes, and 160 people call. That means altogether you spend 4.5 times 160 minutes worth of telephone time. Again, a lot of them is waiting really, but there are different lines is used when different people are waiting. So altogether 720 minutes worth of telephone time is used. If 720 minutes of telephone time is used, and we know that is equivalent to divided by 60 equals to 12 hours of telephone time. 12 hours means 12 hours times 60. 12 hours times $5 is altogether $60 you have to pay for the telephone company. Well, the next question is a little difficult one. In this question, what is the utilization of this company? Well, let's look at the fact again. Utilization is easy, P over AM. we need the processing time, we need the inter-arrival time, and we need the number of servers. Well, the processing time is pretty easy. The average development process is 28 months, right? A is the inter-arrival time. What's the gap between two successive arrivals? Remember, it receives a patent every 7 months. That is, inter-arrival is 7. M is the number of servers, in this case number of development centers, that is 5, comes out to be 80%. Okay, the next question is, again, this question asks you weight plus processing. So let's find the weight first. Weight TQ. Now again, we have to find, this is a multi-server, so we have to use the more difficult formula. Alright, P over M times U, this different formula, 2M plus 1 minus 1 minus U times CVA square plus CVP square divided by 2. We already have P. P was a processing time of 28 months. M is the number of servers, that is 5. U, we already have at 80%. We already have 5 plus 1 minus 1 minus 0.8. Now we need to find CVA on the side. CVA is the standard deviation of the inter-arrival is 7 months and the average is 7 months. So 7 divided by 7 is 1. CVP, on the other hand, the standard deviation is 56 and the average is 28. So 56 divided by 28 equals to 2. Okay, so we have 1 square plus 2 square divided by 2. I would usually let this for you to solve. I'll let the other part for you to solve. I'll do the middle part only. So 0.8. So 5 plus 6 is 5 plus 1 is 6. So root under 12 minus 1 divided by 0.2, or 0.8. The square root of 12 is 3.464 minus 1 divided by 0.2 equals to now 0.8 power 2.464 divided by 0.2. You should be able to do this. You should be able to do the problem from here onwards. How many products does the manager have in a pipeline? Well, this is just about I equals to RT. R is 1 over 7 because R is the inverse of the inter-arrival time. T is, now, this question is not done, sorry. So I calculated, I got this answer to be 40.39, but there is another 28 months of processing, making it 68.39 months. So in this question, the total T is 68.39, making this problem answer 9.77. So there are 9.77 products in the pipeline at a given time. I will allow you to spend time to find this in the slides. First come first serve is by far the most popular sequencing method in the service industry. Give me an example of this violation. There are a lot of examples, including Swift checkout in Walmart and things like that. Whatever the logic could be, there's people who are only buying 2 things to not within the lines. What is the argument against appointments? Where people sometimes don't swap and it really doesn't solve the right problem. It's one of the 2 bigger problems. All right.